Hello my friends, welcome again to my video channel. Today we will start a new project. Her Majesty Watkins Johnson HF-1000. A very famous shortwave receiver built from the 90s of the last century up to 2005 or 2007, as I know, as I have seen in the net. It was very famous in those days, rather expensive, beyond the price level of Drake lines, as I know, also beyond Collins, or maybe in the range of Collins. It was used by military and other intelligence agencies for observations in the shortwave range. The receiver receives between 10 kHz and 30 MHz in all modes, with scan modes and whatever we can think what is possible. It is done with this receiver. It is here on my workbench because a friend of mine, who is the owner, the proud owner of this receiver, has a problem, and he asked me whether I can help. Okay, I will help him, no problem. I say yes. In this case, to get my hands on such a receiver, I don't say no. I would be crazy. My first impression was, when I opened the receiver, where is the money? I don't see it. We have two boards. A third board, that's the front panel, the display unit, with all switches, displays and so on. Okay, here is one component missing. We will talk about it later. That's the reason why it is on my workbench. But it's mainly two boards. This receiver is a digitized receiver, but the digital signal processing is done on a very, very low frequency. The concept is that the first IF is 40.455 MHz, 40.455 MHz. The second IF is 455 kHz. The third IF is 25 kHz. And these 25 kHz are fed to the DSP processor, to this unit, where the demodulation is done, where the filters are built or calculated. It's a calculation, digital calculation and so on. This is all done on this board. This is a truly analog board. This component here is an additional preselector. We can see it here, the preselector. The antenna input is here. The output of the preselector goes to the input of the analog board, to this board here. When the preselector is not installed, the antenna is connected directly here to this input. Here we have some outputs for IF output. I think this is 455 kHz, and other outputs, inputs, speaker, audio and so on. This is a remote control input. There are some options installed, other not. This is the most important option, I think. But in general, it is a very lightweight receiver. It is not heavy. And even when the PSU, the power supply unit, which is here, is installed, it is not very heavy. Well, again, where is the money? Well, it's a question of marketing. Okay, now to the problem. And now I think my question is answered. Where's the money? The money is in the speaker here. The speaker is a little bit bigger than other speakers from those receivers. That's the reason for the high price. And this is most probably the problem, the switched mode power supply. My friend told me that they had a problem some years ago with the receiver. Suddenly the display was blinking with a frequency of some hertz or so. It appeared, disappeared, appeared, disappeared. Seems that the power supply tried to start and then it shut down, started again, shut down again, and so on. This is a clear indication that the problem is in the power supply. Maybe it is outside the power supply, that there's a short on one of the boards. Could also be. It's not necessarily the power supply, but it is a known problem of this receiver. And also in the net I got some information about it with a circuit diagram and other informations from other old men in the net regarding this receiver. My friend wants to swap all electrolytic caps. He bought them, all necessary capacitors. I have them here. I will do this job. I think it's 17 or 20 electrolytic caps, not so difficult to swap them. They are all accessible very well, can be soldered rather easily. So my first check is, or my first work is to swap the caps and then check the power supply. I did not switch on the receiver with this power supply. The danger that I create more damage is rather high. So I will first swap the capacitors, then check this power supply with some load, of course. Load output voltage is plus and minus 12 volt and plus 5 volt. It only supplies 3 voltages. There's a connection for the line, for the 230 volt, and the switch goes to the switch. There is a ground connection, as I see. This is maybe to the front panel. Also some that's the feed in for the front panel, and that's for the one of the boards. Okay, first step is to swap the electrolytics. I don't show it to you step by step, makes no sense. You know how to swap them. Only one hint: always use best quality of electrolytics you can buy. Use the electrolytics for 105 degrees Celsius, not for 85 or so. Buy the higher temperature ones. It costs not much more, but it is a good invest to have the better quality electrolytic caps inside. As I see, there are no tantalum caps. There are only electrolytics and some ceramics and foil capacitors. Oh no, only some foils, but no tantalum caps. This one is also no, it's a ceramic. Well, I will start and show you the result. All electrolytic caps are out, and now we have a look at the catastrophe. I found 7 or 8 leaking capacitors. This one. Here I'm not sure. This is obviously okay, and the big one is also obviously okay, but the big one, it's a filter cap for the rectifier on the 220 volt side, but as I see, it has a loss of capacity or a bad ESR. I will check it more precise, so this also has to go. I never found so many leaking capacitors on such a small board. It was an absolute necessity to swap all electrolytic caps and replace them by new ones. With this capacitor here, we had a rather big damage in the board. The PCB was etched nearly through. Everything was black. I had to use a lot of cotton swabs to get it out, and a dentist tool to scratch it out. It's like a bad tooth to scratch it out. Then I had to clean it. I used some gasoline, cleaning gasoline. Luckily the traces are on the bottom side. The traces are here and they are still okay. I will check it, but it seems to be good. So the damage here on this side is only on the surface and a part of the board, but it's not a copper problem. So this is okay, but it has to be cleaned very thoroughly to remove all acid or residues to prevent any permanent damage and any permanent etching. As long as there is some acid, it will continue its bad work. Just for a short check and to get better access to the board for cleaning, I took out this rectifier diode CR9, this one, and to check it, because this is a rectifier diode for the capacitor, which is faulty. We can see it here. This is a C23. This is C23 where we had the problem, and this is a diode. the rectifier. And this diode is driven by the transformer from the switched mode, from the switching transistor. And when this capacitor goes faulty, maybe it creates a short, so the diode will also die. Or when the diode is conductive in both directions, then the capacitor will get AC. This is also not nice, but the diode is okay. I checked it with a voltage drop. It is 0.58 or so. It is near 0.5 volt in one direction. The other direction is infinite, so I can say that this diode is okay, and I can resolder it. All electrolytic caps are out and swapped, replaced by new ones. These are the old ones. We will have a look at them later and discuss the item regarding the capacitors. I prepared a first check, a first test. I have here an electronic load. It's set to 1 amp. It's connected to the 5 volt. The 5 volt output is stabilized and can be set with the pot. For 5 volt, the other outputs for the plus and minus 12 volt are not loaded, but it's not necessary, because when we have a 5 volt load, then the switch mode power supply is sufficiently loaded. The input voltage is specified between 100 volt and 240 volt AC, so I will start with 100 volt, 110 and increase slowly to 240 volt. We can see here the voltage, the current flowing and the power. Channel 1 is this one, is switched on. Now I increase the input voltage, and when I reach 100 volt, 110 volt, I have 5 volt. Why is there no current flowing? It is not switched on 1. Okay, I have to switch it on. Now the voltage dropped a little bit, 4.98 volt to 1 amp, down to 1 amp. When I increase the input 150, it is 200, 220, that's 220. It is running properly, we have 5 watt. And then I can check the 12 volt output. They are connected to this pin. There are also the 12 volt output voltages, and I will check now. The minus pole is connected to the ground. As I see, the blue one is plus 12 volt, that's blue one. That is plus 12 volt, that's okay. And minus 12 is violet, the next one. Minus 11.8, okay. And orange is plus 5 volt again. 5.1. Okay, this voltmeter says maybe the voltage drop here over the bad connection. I have not a perfect plug here, so maybe the voltage drops a little bit. This may cause a difference. I will quickly check it here if possible, get the accuracy. 5.03, okay, a little bit less. 4.98. Well, that's not important. Important is that the switched mode power supply itself works. Seems to be okay. Now we'll bring it back into the receiver, but I will not plug on the connector to the boards. I only plug on the power supply for the AC input line. By the way, of course, I connected it with an isolation variac. Which also is an isolation transformer, to be more precise and to be on the safe side. Now a measurement of some capacitors. In general, they have still their capacity, and also the quality factor of the dissipation is okay. So it looks not like an isolation problem, but some are at the lower end of the tolerance, minus 10% or so. I will show you. For example, this one should have 390 microfarad. And when I connect it, I'm measuring at 120 Hertz at a low frequency. 390 microfarad it has 360. Quality is okay. So it's obviously not an isolation problem, but we have a low capacity, minus 10%. This is not perfect. This one should have 47 microfarad. A little bit tricky to get the contact without a short. 47. It has 41. Quality is bad, 3. Or the dissipation factor is tangents delta. That means the angle, the error. It should be 0, but the tangents delta is 0.3. That's a rather big angle. So there's some ohmic component and loss of capacity. Maybe it's an ESR or so. And this one should have 1000 microfarad. Measured at 120 Hertz, it has 912, 908, jumping around, and a little bit bad quality also. So there are capacitors which are not good. Others still measure okay, but that means nothing. They have to go. And now to the big one. This was the capacitor behind the rectifier on the AC side, which rectifies the 120 or 240 volt AC. Should have 120 microfarad. And it has 108. Quality looks okay, not so bad. I will measure the ESR with my ESR meter now. But okay, 108 instead of 120, and at 1 kilohertz, 91. That's normal. The capacity drops with a higher measurement frequency due to the inductivity, but with 120 hertz, it is at the lower limit. Not so good. I replaced this capacitor by another one, by a new one, which has 150 microfarad, just to compare it. 120 hertz, and this should have 120, has 108, and this one should have 150. And surprise, surprise, 150 is 130. And at 1 kilohertz, 85. Quality is dropping. Maybe if this capacitor were stored, I take the other one a longer time on stock. $128 looks a little bit better, should have 150. Quality is better at 1 kilohertz. Okay, not the best one. There is a timestamp on it, I assume January 2017. I assume it's a date, I'm not sure, but I think it's a date. It's not a very new one. But now let's have a look at the ESR. This is a measurement of the original one. Capacity is 113 instead of 120. Looks a little bit better. Maybe the measurement is made at DC. And the ESR is 0.5 ohms. It's not bad. So let's compare it with a new one. ESR 0.76, capacity 137. Losses are in the same range. Take the other one. same result. What can we say? This one is, I would say it is still more or less okay. But I swap it, or I swapped it, as you see. It's out, and I replaced it. I've checked all three ones. I bought three, and the obviously best one, and maybe the time on stock is a little bit long for these capacitors, so they need some time for reforming, getting better. And I did another trick, and that's what we see here. I switched a foil capacitor in parallel to this capacitor. Why did I this? It has 100 nanofarad, 630 volt DC. It's an MKP4. It's a metal foil capacitor, not a ceramic. Not use a ceramic one, because the pulses, the electrical pulses from the switched mode power supply are not good for ceramic capacitors. Ceramic does not withstand mechanical stresses over the long time. It gets cracked, and that's not good. Foil is better, because foil is a little bit more elastic, and it will withstand the mechanical stress better. This is not a perfect choice. They are from this manufacturer, it's Wima. There are also, as I know, FKP or FKS, I think FKS capacitors, which are especially designed for switched mode power supplies. This capacitor is for general applications, also for switched mode power supplies. But the other capacitors, I wanted to buy someone. They are not on stock on my distributor here. I have to order it online, and it's not cheap, and I think it's not necessary. Such a parallel capacitor will take some of the pulses and protect the electrolytic capacitor a little bit. I'm sure it will help. Whether it's really helpful over the time, I don't know, but on the other hand, it's not bad to have such a solution. So I did it. Here we have the capacitor, and this is one of the big one, and this one is in parallel. Well, that's it. I will bring back it into the unit and do a first test in the unit and the receiver. This is the final test setup before I plug in the power supply into the boards. The power supply is installed. It's connected to the line. It is switched on. The LED here is not lit because the plugs are not connected, so I assume it's an LED on the low voltage side. We have no indication at the moment, but the voltage is present. We have output voltage 12 volt and 4.85 should be 5. I have a load current of 2 amps. The voltage dropped a little bit, maybe caused by these relatively bad connectors, which are not perfect. That's not important. I will let it run now for at least 1 or 2 hours to see whether it is stable now, whether the thermal capability and the other parameters are okay. And then I can connect the plugs to the boards. Wait and see. The long-term test of the power supply was successful. It didn't get hot. No sound, no smoke, no big bangs or so. Then we can plug it into the receiver. Just one word to the connectors. These Molex connectors are not a perfect solution. Let me say this word, not perfect. The principle is we have here a contact, this shape, and when the pin slides in, this contact is squeezed down and it makes some contact only on one side. The other side here is only plastic, and the plastic generates a counter pressure which is necessary to squeeze the pin onto this contact. Over the years or decades, these connectors may degrade. They will lose their tension, mechanical tension. Also look whether they are still clean. Look into it from the front side. And then we can see whether contacts are all present, whether they are damaged. Sometimes these contacts are damaged by some abuse or so. Well, that's it. And now let's plug it together. Let's switch it on. Looks nice. Tuning, detector mode. Speaker works. Bandwidth can be set. So that's the advantage of the digital mode. The bandwidth can be set nearly without any limits regarding step, squelch, okay, not synchronized AM, I think, AM, FM, sideband modes, but no ticks also. These are channels, okay. Scan modes. RF input. I have to check the manual. There's a gain control. Does not move the S meter. I will connect a signal generator and to see whether the basic functions are okay. Maybe the manual gain does not affect the S meter or I do something wrong. Anyhow. Well, but in general, there's no ticking, no hiccup mode also. It seems to work stable. I let it run now also for an hour or so to see whether it's okay or not. But I think it's now okay. It was only the bad power supply. It's a known problem with these receivers. And now I will connect a signal. We have an input signal, 28 megahertz, received in USB. The level is set to minus 110 dB M. It's indicated here. Minus 110. I go to minus 100. Okay. 90, 80, 70. Oh, it's rather good. 60, minus 50. The S meter follows. Minus 30. There's a little offset. I don't know whether my generator has a problem. Okay. There's a small attenuation in the preselector. Maybe when I would connect it directly to the input. I will test it. A moment. Now it's better. The input is directly connected to the board, to the RF board, bypassing the preselector. Then we have minus 30. Minus 20, and that's 0 dBm. It's nearly perfect. A short sensitivity test. The signal is 0.5 microvolt in the input. CW bandwidth is 300 Hz. You can set this way. Detector mode CW. RF input normal. The S meter is independent whether we choose preamp or attenuator. With preamp a little bit better. It's rather sensitive, as specified. Well, I think it's okay now. There are a lot of keys and functions. I do not check them all, it's not necessary. The problem is solved, as I see, and the unit can go back to the owner. The Watkins Johnson HF-1000 is ready now. The problem was indeed only in the power supply, in the switched mode power supply unit. There are some hints in the World Wide Web that this is one of the main problems of this receiver, obviously. And whenever you have a ticking or blinking display, look for the power supply. Swap all electrolytic capacitors, replace them by new ones, good ones, and then I'm quite sure the problem is solved. Also observe the power connectors, the plugs of the power supply. These Molex connectors can sometimes cause trouble, which has a similar indication on the front panel. It's not necessarily always the electrolytic caps. Sometimes the Molex connectors are dirty, are bent, and cause a problem. Well, is this receiver worth its price? Everybody has to decide it for himself. I don't give a comment. It's a nice receiver, a very good one. I think it's one of the best receivers on the market which can be bought and paid. Others are also good. It depends upon your personal opinion. Thanks for watching. Stay healthy, stay tuned. See you on this channel.